Okay, so we're about to get into what are called left, right, and two-tailed tests. And this is kind of a small distinction, but it's something that's going to be important a little bit later on. And it's not too hard to kind of grasp. I'm going to draw three normal curves here. So there's one, there's two, and there is three. Okay, so when, let's fix that one a little bit. There we go. Okay, whatever. All right, so what we're dealing with is this number, what we're going to call alpha, okay? And the alpha is what we call the significance value. And basically this means that this is the percentage of the time that we get it wrong, okay? That when we, the percentage of the time where we fail to reject a hypothesis and we should have rejected it. Now, normally we set alpha to 0.05. If it's a more sophisticated process, we might drop it all the way down to 0.01. Or if we're testing something that's not so important, we might make it 0.1. Okay, and we're going to have what are called a left tail, a right tail, and a two-tailed test. See, we only want to have error in particular places. So in a left-tailed test, I only want the error to happen if it's to the left of where I want to be. So my alpha of 0.05 will be there. In a right-tailed test, I want my alpha of 0.05 to be on the right. And if I have a two-tailed test, I want half of my alpha. So alpha over 2, which is 0.025, and the other alpha over 2, which is 0.025, to be in each of the tails. Okay, so if I miss here, I want to miss to the left. If I miss here, I want to miss to the right. And here, I can miss to either side. What these correspond to is when I have an alternate hypothesis that has a mu or a proportion that is less than some value. So when I have the alternate, which means that I should be rejecting the null hypothesis and I goofed it up, then the alternate is telling me I should be less than a particular value, which means I should end up with my error on the left. If I am making the same mistake, but the mean or proportion is greater than a particular value in the alternate hypothesis, then I want it to the right. And if the alternate hypothesis says that the mean or the proportion is not equal to a particular value, then I want to be dealing with a two-tailed test, because I could miss either to the left or to the right, but I want half of my error on each side. So what we're going to be looking later in class is we're going to give you some examples of claims that are going to be written as a null and an alternate hypothesis. You have to identify whether it's left, right, or two-tailed, and then we might give you a claim and ask you to write the two hypotheses, and then tell me whether it's a left, right, or two-tailed test. All right, so that's it. There we go. That's left, right, and two-tailed tests.